Hey guys, this is IXL X3 part 2. So I just wanted to do a couple more examples of finding the probability of independent and dependent things. So what I did here is I took an example. It looks the same. It's got the same three cards in both of them. It's both the probability of a prime and then a prime. The difference is this middle part here. This first one says you pick a card, put it back, then pick another card. Second one, you pick a card, set it aside, and then pick another one. So that difference here is the putting it back versus setting it aside. If you put it back, you're taking out of 3 cards the first time and out of the same 3 cards the second time. That makes this one independent because you put it back. The second one, if you pick out of 3 cards, set one aside, the second time you're only picking it out of 2 cards. So that means this one's going to be a dependent because you set that one aside, it changes the second time you pick it. So finding the probability is a little bit different because one's independent but one's dependent. So I'm going to go and find the probability for each one of these. So in the first one, it says you pick a prime and then pick another prime. So up here, I want to look at these 3. You figure out which ones of these are primes. 5, remember prime means you can only divide by 1 and itself. You can't divide it by anything else, right? So in this one, 6, I can divide 6 by 2 and 3. So 6 is not prime. Only 5 and 7 are prime numbers. So for the first one, so we're always going to do 2 events, event 1 and event 2. So in the first event, I'm picking out of 3 cards, and there's 2 prime numbers, so there's 2 options out of those 3 cards. All right? So I pick my card out, I put it back. So now I'm picking the second time, same 3 cards, I still have 2 primes out of 3 total. Right? When we do compound events with 2 different events, we need to multiply. So we're going to go across 2 times 2 is 4. 3 times 3 is 9. Right? After you do that, you've got this here. You always need to check to see if it will reduce. Right? You can do that. If you've got an n-spire, that'll do it for you. You can always Google reduce 4 over 9. It'll tell you what it reduces to, or if it will reduce or not. Right? This does not reduce, so 4 over 9 is the answer here. Right? So that's the independent version. So you pick a card out, put it back, pick it again. The second one, this is the one we're going to set it aside. So for event 1 and event 2, and we're going to multiply our 2 things here. So event 1, same as we were doing before. There's 2 prime numbers out of 3 total. So the first one is still 2 out of 3. For the second one, since we set it aside, now we're only going to pick out of 2 cards. There's only 2 options here. When you're doing this, when you do event 2, always assume that event 1 went according to plan. So I'm going to assume that I got my prime number and we're good. So that means one of these prime numbers is gone. So now I either have 5 and 6 or 6 and 7. Either way, I now have, between these 2, I've got 1 prime number between the 2 of them. So I'm going to have 1 over 2 for event 2. Right? So I'm going to multiply those. 2 times 1 is 2. 3 times 2 is 6. 2 out of 6, and you see if that will reduce. That does reduce. Becomes 1 over 3. In this case, there's a 1 in 3 chance that you'll get a prime and a prime. If you put the card back, you have a 4 in 9 chance of getting a prime and then a prime. There you go.